All right, so as you know, we are going to be learning Python programming this semester. And we're going to go over some of the concepts in the first chapter of the book. That's called The Way of the Program. Kind of a funny name for a chapter, I suppose. Um, so we're not going to do any programming in this chapter. We're going to just look at basically what a program is and what it takes to get a program to run on your computer. So the first thing that we're going to talk about is just the concept of taking programming languages like Python and other languages and categorizing them into something called high-level languages and low-level languages. Okay, so Python is an example of a high-level programming language. And in order to kind of answer the question, well, what is a high-level programming language, which makes it high level, we kind of need to contrast that from a low-level programming language. Now, you may have heard, probably sometime that, oh, computers only understand ones and zeros. And that's true. So computers are built to run on electricity. And so when we talk about ones and zeros, what that really is there's some threshold of a voltage of electricity. And if it goes above that threshold, then we treat that like a 1. And if it's below that threshold, we treat that like a 0. So really, computers deal with, higher levels of voltage and lower levels of voltage. And those are its ones and zeros. And then it's able to convert data into ones and zeros, instructions into ones and zeros, and most importantly, it's able to use ones and zeros to represent true and false to do logical operations. Okay, and that's how computers are able to execute instructions and things like that. So that's just the very brief overview of how the ones and zeros are involved in a computer. If you were to take a course in, let's say, discrete math or in digital logic, you would learn a lot more about how computers are able to use ones and zeros to do what they do. But we'll just leave it at the kind of high-level abstract concept for now, because that's not what this course is about. Anyways, so you've heard that machines only understand ones and zeros, and so a processor is designed, okay, to use those high and low voltages, those ones and zeros, to execute instructions and to do certain operations. And so if you look here at this example, okay, if we fed this to a computer processor, it would know what to do with that. It would convert that into, oh, I need to add these numbers or move this piece of data here or compare this piece of data and go. It knows what all those ones and zeros mean. Okay, now if you were intimately familiar with the way that the processor was designed, then you could just send it the right sequence of ones and zeros to make the computer do anything that you wanted it to. Okay, so that is what we would call machine code, when you send it those ones and zeros in a very specific sequence so that it knows exactly what to do. Now, most people aren't very good at programming in machine code, figuring out the sequences of ones and zeros to give to the machine to make it do what you want to do, because that's very low level. That's talking the machine's language. Okay, and so to make things a little bit easier, people have invented something called assembly language. Sometimes people call it assembler. That's a little bit of abusive notation. Assembler is actually a program that translates assembly language into machine code. So anyways, assembly language looks more like this. Now, it's still a low-level programming language because it's tied directly, like a one-to-one mapping between an assembly language instruction and a machine code instruction. So I might say, okay, well, this means load the number 1 into something called a register A. So load A with the value of 1. Okay, so if I know that the machine, if I send it the right sequence of zeros and ones, it's able to put 1 in this register, which is just a piece of memory. Sorry, I have an Amber Alert. So where were we? If you know that that's something that you need to do in machine code, it's much easier to write an instruction like load A with the number 1 rather than 10101000, and you get the idea. Okay, and so if you, again, you would have to have an intimate understanding of exactly how the processor is designed and exactly what it can do, but it's a little bit easier to write these assembler instructions because we have a little bit better idea of what those mean. And then those can get converted and translated into machine code. Okay, but still a very low level. You have to be intimately familiar with the way that the processor is designed to be able to write in assembly language or assembly code. Okay. Now, you may be glad or not glad that we are not programming in a language like that. We are programming in Python, which is a high-level language. Now, a high-level language looks a lot more like English. It looks a lot more like the way that you would write down a solution to a problem. And so the nice thing about a high-level programming language, you don't have to have an intimate understanding of the processor. It's completely independent from a particular type of computer. It uses English words, mathematical symbols, and it makes it look a lot more like your everyday human language and not like machine language, what the machine is able to do. So here's an example of a piece of Python code. You might not have any idea what it does, but if you look at it, you can see English words in there like, you know, for item in list A, if item not in list A2. You see the words like append, words like print. So these things, you can just look at and have an idea, okay, well this probably prints something, and this if something not in this, you're trying to probably check if something is in something else, that kind of idea. You can, it looks a little bit more like English language, a lot more than LDA #1 STA 1000 LD. Like, we don't really even understand what that means at all. Whereas these look a little bit more like English words. Okay, so we will be programming in a high-level language. It still takes work because you need to learn the language, but probably a little bit less work than programming in assembly language and a whole lot less work than programming in machine code. Okay, but if we're going to program in a high-level programming language, we have to realize that the machine itself, the processor, doesn't understand something like Python or Java, or you pick your high-level programming language. It only understands machine code. So sort of what we're eventually going to have to do is figure out, well, how is it going to get from a high-level language that we write in that's a little bit easier for us to understand into machine code, which is the language that the machine understands. And we'll get to that next time, but for now we're going to just talk a little bit more about low-level programming languages and high-level programming languages. Okay, so there are obviously, and you might even be able to think of some without, even if you've never programmed, what advantages of high-level languages might be. So first of all, it's much easier to program in a high-level language. It looks a lot more and reads a lot more like English language. So what do we mean by easier? Well, that means, first of all, it takes less time to write it because when we're writing it, it's a little bit more the way that we think and process things, as opposed to the way a computer processes things. Also, the programs that we write tend to be shorter and easier to read. They're shorter because like a processor's instructions are very, very simple. So where I might say, add A and B, it might take 6 or 7 instructions for a processor to be able to actually do that. And so every high-level language gets translated into many, many low-level languages, instructions. And so when we write a high-level program, it's going to have much less instructions. It's going to be shorter. And because it's shorter, it's easier for us to read it and comprehend it. And it has more, abstract ideas in it instead of really detailed instructions in it. Okay, because it's shorter and easier to read, that's going to make it easier to modify or change if we ever need to modify or change the program. Easier to maintain and update for other people. You might come in looking at a program that somebody else wrote, and it's your job to either modify that or update it to make it work on a different system or something like that, or to cooperate with a different piece of software or something like that. And it's going to be much easier to do those kinds of tasks when it's easier to read it. Okay, also it's more likely to be correct. So imagine, and if we go back to this previous slide, if there was some error in your program and this is all you had, 10101, like it would be very hard to find out like an error in there. What if I skipped a 0 or transposed a 0 and a 1 somewhere? It's really hard to just look at that and tell that that's what I did. Okay, but if we came down here, okay, this is in Python, it's going to be a lot easier to see, oh, I made a mistake by, not putting a colon somewhere that I was supposed to, or I accidentally, you swapped the not in the word not and in. Okay, that's going to be a lot easier than finding a missing 0 or swapping a 1 and a 0, right? You can, when you look at it, almost kind of reads like English, and so those kinds of errors are going to be easier to find. And so and just the fact that we can find our errors more quickly also leads to the fact that it's going to take less time to write a correct program, because we're able to, any errors that might creep in, we're going to be able to find them and correct them more easily. Okay, so definitely easier to program. A second advantage of high-level languages is that they are portable, which means that they can run on different kinds of computers. Again, so going back to this one, so this machine code, these 1s and 0s, is very specific to a specific kind of processor in my machine. Now, if I took these 1s and 0s and gave it to a different processor, it would mean something completely different. Okay, and so this machine code is very, very tightly tied to the processor. This sequence of 1s and 0s is only understood by one particular processor. Okay, not true of a high-level programming language. This is completely independent of what the machine below it is doing. These are high-level concepts. I just have sort of abstract ideas of what I want to do, and I could run this on any processor. Now, of course, we'll get into this. It's going to have to be translated for that processor, what this means, but I could run this on a Mac or a PC, and like any processor that's in my PC, like as long as I have the right, translation process of getting it into something that the machine understands, I don't have to write this for a specific machine. It's completely independent from that, and that's what makes it portable. It can run on any kind of computer. Now that, of course, takes work, but that's an advantage of it, is that I don't have to think about what kind of computer it's going to run on. I can run it anywhere. Okay, so typically you'll see, in textbooks that languages will be divided into two categories, high level and low level. But if you go and search on the internet, you'll probably find that programmers really think of languages more in a spectrum, or as opposed to just two categories, high and low. Okay, and so if we were to look here, like the highest level languages would be human languages. And at this point, we can't program in a human language like English or Chinese or Spanish or Russian. So we can go with these high-level computer languages, and we might even have high-level and very high-level languages. Okay, and then we would have these middle-level languages, that have some high level concepts, but also are able to kind of speak to the hardware as well. So there's kind of a mixture of high level and low level. Then there's things that we would call low level, and at the very bottom, like binary code down here that only the machine understands, that would be like the hardware level. That's the lowest level. Okay, so there's this kind of hierarchy or spectrum of languages. It's not just straight low level and straight high level. I got this picture off of the producers of something called Live Code, and they're trying to, sell you the idea that their programming language is the most efficient, it's going to be very fast for you to write programs. And so this is the hierarchy that they show. They've got these like high level languages, and then these are going up in level. So these are higher level languages, and even higher and way at the top is Live Code. Now, whether that's true or not, I don't know. I don't actually know Live Code. But you can see the idea here in this picture that it's not just two levels of languages, high and low. There's this whole hierarchy. As we go, we get sort of a higher and higher and higher level language. I also liked this picture that I found. It kind of gives us a good idea about some of the advantages of high level languages. So notice this one right here is the level of the language. Okay, so again, it has a spectrum. So binary code is the very lowest level. Okay, and up at the top, it puts these kind of scripting and interpreted languages like Python. And then in the middle between those, there's C and C++, also a high level language. Maybe C is often considered sort of a middle level language because you can do a lot of low level type things in C. Assembly language, okay, would be on top of machine language. And way down at binary is the lowest level. Okay, so this is the highest level language, the lowest level language. And then over here, you'll notice, okay, human readability, very high for high level languages and very low for low level languages. So this is one of our advantages. It's easier to read, easier to program in these higher level languages because they're much more like English languages and much less like a bunch of ones and zeros. Okay, but they also, that readability and usability comes at a cost. So notice here, the program execution speed tends to be lower for the higher level that you go. Okay, if I were to write code that's straight in binary and a bunch of ones and zeros because I had an intimate understanding of the processor and how it worked, I would get the best performance. It would run the fastest. Okay, but the more abstract I go and the further away from the machine level I go, probably the less efficient my program is going to be, and I'm not going to get execution speed. So if you think about like embedded systems and things like that have to be very efficient in terms of small programs and running very quickly, you might see things that are written more in C or embedded C or something like that because they might be able to run faster than these other higher level languages. Okay, so that is sort of the summary of the difference between high and low level languages. This is a nice little summary here. If I only had one slide to give you, this has all of the description, examples, so you can kind of wrap your brain around the difference. So again, this is just, high level, low level. Two categories. It's not putting all the spectrum that's in between there. But high level are things like Python, which we'll be learning this semester. And then if you go on in computer science, you will learn things like C++ and Java. Those are also high level languages. The descriptions are independent of hardware. That's an advantage. and then they can be translated using either a compiler or an interpreter. And that's what we'll talk about next time, how to interpret and to translate these languages. And the idea here is whether you use a compiler or an interpreter, one statement will translate into many machine code instructions. So there isn't this one-to-one correspondence between the machine and the language that you're writing in. Okay, so it's very easy to look at and read and understand because you just see things that you would see in math or just in English in general. Something like, oh, pay rate equals 7.38. Hours equals 37.5. Salary equals pay rate times hours. Those things, it almost looks like an algebra kind of statement, right? Okay, so these are much easier to read and write, easier to check for errors. Okay, that's sort of a summary of high-level languages. Low-level languages, there's really kind of two low levels. The lowest level would be machine code. That's the binary, the ones and zeros. Okay, and those ones and zeros would, I suppose you could write them, but usually, I mean, people don't usually write in binary code. Usually that's produced by a compiler or an interpreter or assembler, rather than a person writing out all the ones and zeros. So the ones and zeros that you see here, I mean, this means something to the machine, but to us, like, we have no idea, is it one of these statements or something different? It's not very readable to us, only the computer understands it. Okay, also low level is assembly language. There's a one-to-one correspondence between a string of ones and zeros like this and an instruction, an assembly language instruction. But they give names like this one, add 9.3. Like, I don't know maybe exactly what the 9.3 is in there, but add, that kind of makes sense to me. So that's easier to see, something like add, and then as long as I knew the assembly language and what the numbers after it meant, okay, then this would make sense to me a lot more than a string of ones and zeros. But there is just a direct correspondence. One of these instructions translates in one machine code instruction. And so to program an assembly language, you still have to have an intimate understanding of the processor's design and what it's able to do so that you can program it. Okay, so that is the difference between high and low level languages. I know that's sort of an abstract. If you really want to understand the nuts and bolts between the differences, you're probably going to have to learn a high-level language and learn a low-level language, and then you'll be able to see the comparison between them. So again, if you went on to in computer science, you would take an assembly language programming class and learn how to program in assembly language and get some experience with that low-level programming. But in this course, we will just stick to the high-level language of Python. Okay, next time we're going to get into how to translate from a high-level to a low-level program. So I will see you in the next video.